Okay, so yesterday we left off on a word problem. I was a little flustered because I looked at the book and saw that our answer was off. And so going back, I realized that it wasn't part of my setup. It was part of me putting something in the calculator and then transposing it back and reading it wrong. And so when I had take the calculation, there was a person who put in $1,000 in a month into an account that got 6.8% compounded continuously. And she could put it in for 3 months, and she did, and she then took it out. So we plugged in this information into the equation, $1,000, 0.068 is decimal form of the percent, and 3 months we had to convert into years, so we got 0.25. When I put that in the calculator, that's the point I got wrong, which was down in here. So it should have been $1,017.15 about. She took that money that she earned after 3 months, and then she put it into another account, and it was until May 1st. We figured that was only 1 month left that she put this money into the account. We found out that that account had 5.25% interest, and it was compounded 12 times a year monthly. And so the time period, we had to convert that 1 month into years. So that was the 1/12. And we just plugged that back into the formula for compounding interest. Multiply it by, once we figured that out, multiply it by the amount she earned from the 3 months. And May 1st, she should walk away with $1,021.60 after investing $1,000 to begin with in the original account. So not too much money. I guess, $21.60 in interest. Okay, so there's some other ones in here, and it was kind of interesting. I haven't seen this formula before in an algebra book. And I basically will do problems like this, but I never normally go back. So present value theorem. So the present value theorem, it's the present value P of a dollar to be received after T years. So assuming per annum interest rate compounded n times a year is the following. Okay, so basically, if we were looking at our amount of money that we were going to get if we were putting in some principal, P, that was compounded n times a year, we saw that that was A equals P, all times the quantity 1 plus n over T, all raised to the nt. All they're doing here is they're solving for P. And so if we solve for P, because this is strictly multiplication between P and this grouping or that parentheses, and there's no other term, we can divide both sides by that parentheses. And so if we divide both sides by that parentheses, we'd be left with P. And so P then is equal to our amount of A all over this 1 plus n over T raised to the nt power. Let's use rules of exponents. Let's bring that numerator, or sorry, let's bring this denominator, this grouping back up into the numerator. And we can do that by rewriting the exponent as negative. So 1 plus n over t, oops, yeah, all raised to the n over t. But we brought this up from the denominator to the numerator, so that has to change the sign of our exponent to a negative. Okay, so power to power of exponents rule was multiplication. So our formula for present value of an amount If we want to figure out how much we have to invest to get a certain amount after a certain time, would be this formula. P equals A, all times 1 plus n over t, all raised to the negative nt power. I don't really need that bracket there anymore. So this is for compounding n times a month. So you can do the same sort of idea for compounding continuously. So remember, we found that our amount after a certain amount of time that we have invested or borrowed, and it was compounding continuously, was P e to the RT. So if I want to figure out that present value, how much I have to invest in order to get a certain amount after time t, I could solve for P here. We could divide both sides by e to the RT. So then we know P is the same thing as A divided by, just divide by, sorry, e to the RT. Same idea, let's bring that denominator, the piece in the denominator up. We can change it and make it equivalent by giving it a negative exponent. So P is equal to A e to the negative RT. Okay, so those are, I didn't really want to do that. Present value theorems. Typically, I don't do it that way. I just basically put in the values I know. I know that I'm going to have to solve for P, and then in the end, when I'm doing my algebra, I basically are doing these steps here. This just has done it beforehand, which is a lot of our formulas are just manipulated around in mathematics. So let's look at an example. Okay, so this is all kind of relevant for you guys right now, and myself with my kids going to college next year. College costs. The average annual cost of a college at a 4-year private college was $34,740 in 2017-2018 academic year. This was a 3.6% increase from the previous years. If the cost of college increases by 3.6 each year, what will the average cost of the college at a 4-year private college be for the year 2037 through 2038 academic year? Okay, so let's go through and let's pull out what we know. So average cost. In 2017/2018. Was 3.6%. Or wait, no, it was $34,740. This was an increase, or it's increasing at a rate of 3.6% per year. So we want to know if, part A, if the cost continues to increase at this rate, what is the cost going to be in the 2037-2038 year? So what will tuition be? In 2000, what did I just say? 37, 38. Okay, so to me, it's only increasing at a rate of 3.6 per year. So that is only being compounded like once a year, which is the same thing as our compounding n times a year. It's just that n is 1. And so our amount, our college cost, is going to equal, well, we have the initial amount that we know, $34,740. And then we have 1 plus our interest rate. Our interest rate is 3.6%. We need to rewrite this in decimal form, not in percent form. So move your decimal over 2 places. And so we have 0.036. And it's compounded, like I said, once a year. So we can think of n being 1. So all times n, the number of times a year, which again is 1, times t. So we have to figure out how long time is.
Why'd you make it 34,700?
Because that was the cost of tuition that was back in 2017-18. And so this, technically, if they give us a certain amount at a certain time period, we're going to usually use that as our initial amount. So we're going to use this as our initial amount.
Yeah, isn't it 740 though?
Oops, you're right. There I go again. 34,740. Okay. And then t. So t is the time, and time is from, we're going to use t equals 0. In 2017. So in 2037, we need to figure out how many years. So t is equal to, well, if you can't see it, 2037 minus 2017, right? So we get back 20 years. This is all times 20 up here. Okay, so simplify. So we have 34,740 all times 1 plus 0.036 is 1.036. And that is raised to the 20th power. So order of operations, you first have to do that 1.036 and raise it to the power before you can multiply it by the $34,740. Unless you put parentheses in the correct places in your calculator. So 1.036 to the 20th gives me about 2.028593 ... Take that number and multiply it by the $34,740. So this is $70,473.35. I don't think they don't want the cents. They're gonna be nice. They're gonna give us a little bit, 35-cent discount. Okay, so this is our average cost of 1 year of private college. And 2037-38 school year. If things continue to increase about at that rate. Okay, so part B. We're a little bit too late, but we maybe be able to plan for our children, or for my case, my grandchildren, because I'm not going to have any more. Anyways, so part B. So college savings plan, such as a 529 plan, allows individuals to put money aside now to help pay for college later. If one such plan offers a rate of 2% compounded continuously, how much should be put in a college savings plan in 2019 to pay for 1 year of the cost of college and a 4-year private college for an income freshman in the year 2037? Okay, so a lot going on there. Basically, we want to know how much we have to put aside. So how much can we invest now to have 1 year of college tuition? In 2037, if it earns 2% compounded continuously. Okay, so if you wanted to memorize another formula, you can use that one that I just explained to you at the beginning of class. Or we can just know what we know about compounding continuously. It's in the form A equals P e to the RT. We know what amount we want back. We want the amount of tuition in 2037. Well, we did that work above. So in 2037, tuition was, or gonna be, will be, about $70,473. So this is what we want our amount to be, $70,473. Is equal to, we're trying to find P, E, our interest rate, well, we're given that that's going to be earning 2%. So 2% is 0.02. And the time. We're saying now, my guess is this book was doing this at the time of 2017, but let's just do it as now, as of today, just because that makes more sense to me. I was going to say, yeah, because they technically don't know what this year is, or who is using this book in what year. So, but it is 2020. So we have how many years? So T for S It's 2020 now, so t is going to equal 17 for us. So if we divide both sides by this e raised to the 0.02 times 17, we would get p is equal to 70,473 all over e. Let me just multiply that out. Well, 2 times 17 is 34. Let me just figure out how many places I need to move the decimal. And we needed to move it over twice. So 1, 2. So that's 0.034. So this is approximately $50,160. Okay, so that was the type of word problems from the 6.7. 6.8, we kind of talked about already. I gave you formulas for exponential growth and exponential decay. And so let's look at a couple of problems dealing with that. Okay, so iodine 131 is a radioactive material that decays according to the function A of t equals to A sub 0, and then E, and that E is raised to the negative 0.087 t. Okay, let me just go back. So this is a radioactive material that decays according to this function A of t, where A sub 0 is the initial amount present, and A is the amount present at time t in days. Assume that the scientist has a sample of 100 grams of iodine 131. What is the decay rate of the iodine 131? Okay, so let's just go back in here. So we have this. We have A of t equals the amount of the material. After t days. And his initial amount was 100 grams. So what is the decay rate? We talked about exponential growth and exponential decay in the form of A sub t equals A sub 0 e to the kt. And it really depended on k. K was equal to the growth rate. If it was bigger than 0, sorry. and decay rate if k was less than 0. So this is the rate of growth and decay. So we can look at our formula that we're given, and we're given that k is negative 0.087. So in percent form, multiply this by 100. And so this would be, it's decaying at a rate of 8.7%. The book says the negative in there. I technically don't like the negative in there because you're already saying it's a decay rate. But I want you guys to get it right in my math lab. Okay, that was part A, by just looking at that. Part B, how much iodine is left after 9 days? So we know what T is. And our time was in terms of days in the problem, so we don't have to convert the units. And so we know T in this case is equal to 9. And so we can go back up in here and we can plug in 9 into our formula. We also know what our initial amount was. That initial amount that we were given, right, was 100. So our amount, A sub 9, is equal to our 100 e raised to the negative 0.087 t, which is 9. So that's pretty much a calculator exercise and being able to plug this in correctly. So when you're plugging this in the calculator, make sure that when you're plugging in this exponent, depending on how you do it, you do the multiplication first, or you put brackets around that whole thing. So e raised to that power, I get approximately 0.457, and then times the 100. So 0.45. So this is going to give us, move the decimal over twice, 45.7. And we're talking about, I'm wondering if they give us, yeah, they round to the tenths grams. When will 70 grams of iodine be left? Okay, so this time we know what our amount is. And we want to find T. So we have 70 is equal to, well, we still had 100 milligrams to start with, e raised to the negative 0.087. But now we're trying to find out what t is. So solve for t, we got to get e by itself. T is in the exponent, and so we're going to use our rules that we were looking at yesterday of logs. So let's first divide both sides by 100. So we have 7 over 10, or 7/10, 0.7, is equal to e to the negative 0.087t. So let's look at this as using natural logs of both sides of our equation. And the reason we chose natural log is because we had a base that was of e. A natural log of e, well, this is our log is base e. Natural logs are just exponents. And so you're thinking, what am I raising e to get this back? E to the negative 0.87t. Well, that's just negative 0.087t. I can't get rid of the natural log over here. I don't know what I raise e to get this back. So I'm going to keep it as natural log of 0.7 is equal to this. Almost there. Get t by itself. Divide both sides by negative 0.087. So natural log of 0.7, end your parentheses, divided by negative 0.087. That gives you approximately 4 years. And the last question for this one is, what is the half-life? What is the half-life of iodine 131?
Wait, 4 years or 4 days?
Oh, thank you. Days. That's a, yeah. Days. We're in terms of days. Iodine. So half-life, basically that is the amount of time it takes for a substance to reduce down to half of its amount. And so our substance, we had 100. And so we want to figure out to start with, and so we need to figure out how long it's going to take to get down to 50 grams. So we need to find time. The time it takes to reduce to half the substance. So in our case, we started with 100, and we want to know, when is this going to equal 50? So 50 equals 100. E raised to the negative 0.087 t. So pretty much like we did last time, we have to first isolate our exponential piece. So this is 0.5. It's equal to e to the negative 0.087t. We're trying to solve for our variable that's in the exponent. So if we take the natural log of both sides of our equation, we can get that down. And even better yet, natural log of e is just the exponent. So we have natural log of 0.5 of natural log of e to the negative 0.087t. So natural log of 0.5 equals negative 0.087t. Divide by the coefficient in front of t on both sides. And then the calculator. So natural log of 0.5 divided by negative 0.087. So I get 7.967. Let me see how much they. And so they round to the hundredths. So 7.967. So 7 rounds the 6 up. So the half-life of the substance is every 7.97 days. So if you know that, how long do you think it would take to get down to 25 grams? So basically it's going to take another 7.97 days from this 50 to get down to half of that amount, which is 25. So it's going to be approximately 7.97 plus 7.97, approximately 16 days. And if you plug 16 back into our equation, we should get about 25. And then if at 12.5 grams would have to take another about 8 days from that 16 days. So things are slowing down. The rate is slowing down as time progresses. Okay, so I also want to give you one other formula, or maybe even two. If I give you a problem like this on the exam, I would give you this formula. I don't have this one memorized. And this one is Newton's law of cooling, and some of you might even have this already memorized because of chemistry. So Newton's law of cooling, maybe even physics. So the formula is U of t is equal to t plus parentheses U sub 0 minus capital T. So there's different types of t's. There's a lowercase t for the U of t equals capital T plus parentheses U sub 0 minus capital T parentheses, and then all times e raised to the k and then the little t. Okay, so Newton's law of cooling states that a temperature of a heated object decreases exponentially over time towards the temperature of the surrounding medium. So the temperature U of a heated object, so U of T equals the temperature of the object at a given time T can be modeled by that function. where capital T is the constant temperature of the surrounding medium. So capital T equals the constant temperature of the surrounding medium. U sub 0 is the initial temperature of your object. Because it's cooling, your temperature is going down. We know exponentially if it's a decreasing, our K value is negative. So K is going to be less than 0 here, and K is the rate. It just says here K is a negative constant. Basically, that's the rate it is changing. K is. Okay, so let's look at a problem. Okay, so warming time of a beer stein. So a beer stein has a temperature of 28 degrees Fahrenheit. It's placed in a room with a constant temperature of 70 degrees Fahrenheit. After 10 minutes, the temperature of the stein is risen to 35 degrees. So we're really actually not looking at law of cooling. Or we can think of this as because the temperature is raising, our K value is going to be positive. So sorry, let me go back. So it's placed at a room with a constant temperature of 70 degrees. After 10 minutes, the temperature of the stein has risen to 35 degrees from that 28 degrees. What will the temperature of the stein be after 30 minutes? How long will it take for the stein to reach a temperature of 45 degrees? See the hint given in problem 15. Hint, you need to construct a formula similar to equation 4. I bet you that's, oh, where's equation 4? Oh, yeah, equation 4 is Newton's law of cooling. Okay, so we got a beer. The temperature of 28 degrees Fahrenheit. It's placed in a room of a constant temperature of 70 degrees, so the room temp. Is 70 degrees Fahrenheit. After 10 minutes, the temperature of the beer is 35 degrees Fahrenheit. So before we even answer any of the questions about how long it's going to take or what the temperature of the beer will be after 30 minutes or how long it will take for the stein to reach 45 degrees, we need to figure out our equation. Okay, so going back up to this, Newton's law of cooling. So we know the temperature of our beer. So let's just call it U of T. This is equal to T. Capital T is our surrounding temperature of what we're looking at. Well, our surrounding temperature, this was 70 degrees. So we're going to put 70 in here. Plus okay, so U sub zero, that was the initial temperature of our item. And our initial temperature of our beer, that was 28 degrees. So let's just simplify that a little bit. But there's we have multiple variables still in here, so we need to use some of the information given to help us find that. So we have U of T equals 70 plus, well, 28 minus 70. That looks like negative 42 e to the kt. Okay,
Why aren't we plugging in the 10?
What's the 10? Oh, the 10 minutes. Yep, that's what we need to use. So now we got to use information they gave us. So this is going to be the general formula. We don't know how to we don't know what K is right now, but we can use this information right here to figure out what K is. So we know when T equals 10, oh, that didn't work. We have U of T, the temperature of the beer is then 35 degrees. So we have two variables now. Sorry, we don't have two variables. We have U of T, yeah, we do. We have U of T and we have T, and now we can figure out what K is. And once we know what K is, then we have the formula that we can answer any question. So we're going to use this information to find K. Okay, so U of T, we know that that temperature is 35 degrees, is equal to 70. Sorry, 70. Okay, plus this negative, I don't really need this, so minus 42 E K, and T at this time was 10 minutes. So we want to solve for K. Let's subtract 70 on both sides. We want to isolate the exponential piece. So if we subtract 70 on both sides, well, 35 minus 70, that's negative 35, is equal to negative 42 e to the, I'm going to say 10k. Divide both sides by negative 42. I notice that 7 goes into both of those. 7 goes into 35 5 times. 7 goes into 42 6 times. Two negatives make a positive. So we have 5 6 equals e to the 10k. Take the natural log of both sides. So natural log of 5 6 equals the natural log of e but natural log of e is just 10k. So divide both sides by 10. Something's wrong. Okay, I'm getting a negative answer, and maybe this is why they said the k. So negative 0.082. But my temperature is increasing. And remember they said K before was negative. So I'm thinking that because we're heating it, that would have taken it in, I'm sorry, that would have taken that into consideration when we did that formula. Let's just keep it that way. So right now I have U of t is equal to 70 plus 28 minus 42. Wait, 28 minus 7, which is negative 42. E to the negative 0.082. Nope, that's wrong. Negative 0.0182 T. Okay, so this is what we believe our formula is to answer any questions. And so part A, or it wasn't really a part A, they wanted to know what is the temperature of the stein after 30 minutes?
Is it 0.082 or 0.182?
I got negative 0.0182, but let me go back and let me recheck it. So natural log of 5 divided by 6. And then I take that answer and I divide it by 10. Negative 0.0182 ...
Okay, I just seen the K above it was different.
Oops. Up above, I didn't change it. There you go. There you go. So what's the temperature? After 30 minutes. So here we know what T is. T equals 30. So plug it in. We can look at U of 30. U of 30 is 70. Well, again, we don't need that plus the negative. So minus 42 e to the negative 0.0182 times 30. Okay, so I got that number in my exponent, so I'm going to take my exponent times 30. I can take it where I can take e raised to my answer. Oops. Multiply that answer by 42. And then 70 minus that answer. So I get back 45.69. Degrees Fahrenheit. And then they wanted to know how long. Okay. They wanted to know how long will it take to reach the temperature of 45 degrees Fahrenheit. Okay, because I'm chuckling a little because we just found our answer that 30 minutes. It was 45.69 degrees Fahrenheit. So I know whatever my answer, my result is, it better be close to 30 minutes. And it is 45.69 is a little more than the 45 degrees, so it should be a little less than 30 minutes when I do my math. Okay, so plugging everything in here, I get 45 is the degree I want equals 70 minus 42 e to the negative 0.0182 t. I have to subtract both sides by 70 to first isolate that exponential piece. Again, we get negative 35 when we subtract that equals negative 42 e to the negative 0.0182 t. Divide both sides by negative 42. Guess what? If you reduce that again, you're going to get 5/6 is equal to e to the negative 0.0182 t. Take the natural log of both sides. So natural log of 5/6 is equal to the natural log of e is always just the exponent. And so the exponent is negative 0.0182 t. Divide by that coefficient. So natural log 5 divided by 6. All divided by negative 0.0182. Something's wrong.
Isn't it supposed to be 25 or negative 25 when you subtract the 70? Not 35?
Yeah, 45. Yeah, that's right. That's where I'm wrong. So that changes this fraction. So when we subtracted 70, that is negative 25. Okay, well, when we divide by negative 42, that does not have common denominator, common factors. So it's just 25 over 42. So we would have had to take the natural log of 25 over 42. Thank you for catching that. And divide that by negative 0.0182. So time is 28, approximately 0.5 is what I get.
So normally on like a test or something, would you have us just use the calculator to solve this, or would you want it just in log form or just like a mix of both?
It depends if I allowed a calculator or not. I want you to be able to do log problems, but I don't want you to be able, yeah. I would allow you definitely to use a calculator on this type of a problem. If for some reason I didn't allow you to use a calculator, there's not very far. I mean, you could leave it as, you would be leaving it at this ugly, nasty number. But you would have had other nasty things in here too because of our value of k would have been in terms of logs too. So to me, I would definitely, I think, let you guys use a calculator for that piece. So that right there is the word problems from chapter 6. Let me just introduce to you the next chapter that we're jumping into. So we're getting into what are called conic sections. Let me pause this. Okay, so we're going to be looking at conic sections, and basically conic sections are shapes that can be derived from taking slices of these right angle cones. And so notice you get a circle if we go straight across. We can get an elliptical shape if we kind of slice it slanting. We can get a parabola shape, or we can get what are called hyperbolas. So all 4 of these are called conic sections. So if it says, you know, determine what the conic section is, you're determining is that equation representing the circle, ellipse, parabola, or hyperbola. So far in this class, we've already looked at circles and parabolas facing up and down. So 11.2 talks about parabolas. And so again, we've already talked about them facing up and down. We looked at them in vertex form. I'm going to actually give you a different type of definition for a parabola. So just kind of bear with me and see if I can explain this, that it makes sense. But a parabola basically is a collection of points P in a plane that are the same distance d from a fixed point F. So there's a set of points P in a plane that have an equal distance to a fixed point F and a fixed line D. So F is called the focus. And D, they do it with a capital D. Capital D is called the directrix. as a result, the parabola is a set of points P for which, as a result, the parabola is a set of point P's points P for which the distance of the point from the focus to the point, that some point P has to equal the distance from the directrix to that same point P. Okay, let me draw a shape. So basically we have some parabola, and there's going to be some focus. That focus, the parabola is always going to be facing towards our focus. And so there's some fixed point in here, and I don't know exactly where it is. And there's some fixed line. The directrix is always a line, and it's either horizontal or vertical, or the only ones we're going to look at. And it's always like below the vertex or on the side of the vertex, depending on which direction. So let's say it's just facing up for now. So I have some directrix like this. So basically it's saying any point you choose on the parabola, this must be the same distance from that point on the parabola to the point on the curve, or on the directrix. So it has to be, this has to be the same distance in here. So maybe d sub 1 has to equal d sub 1 here. So if I chose another point somewhere, anywhere on our parabola, it doesn't matter where, the distance from this point here so let's call it d sub 2 in this case, has to be, and my line might not look great, but it usually forms a 90-degree angle in here. So I'm already off with my picture. This has to be the same distance as d sub 2 here. So I'm not going to prove that. I am just going to now jump into the 4 forms that you can see for a parabola. And we talked about your parabola could be facing up or down. That had to do with the coefficient in front of the x squared value. Same idea, our parabola can be either facing right or left. Okay, so parabolas facing up and down, I'm going to give you a little bit of a different formula than what we had done before. So vertex form. So equation for parabolas, HK, axis of symmetry parallel to the axis A greater than 0. That's weird. So here's our equations for parabolas. If it is the x value, if we're going up or down, it's our x value that is squared. This is in a certain form, and so we can always manipulate it to get in this form by completing the square method. So we have x minus h quantity squared is equal to 4a all times y minus k. in this form, our vertex, opposite signs, just kind of like it was with our circles, is going to be at HK. Our focus, well, this depends on our value of A. Okay, so this one is, shape is like this. They do it a little differently. That graph is a shape like that. To get to your focus, basically you're going to, focus is always where the parabola is facing towards, right here. So our focus, that is a distance of A. And so if this point is at HK, think about it. If you're adding a value of A here, that's affecting your Y value. And so your X value is staying the same. So your focus is going to stay at H, but your Y value of that point is K plus A. So just add that value of A. Your directrix, that's this line down here. And so the directrix, D, let's see, how do they put it? Yeah. Your directrix, it's an equation, this is a horizontal line. So your directrix is the line y equals, well, let's think about it. We know what the y value is here. This distance here I said was just A, it has to be the same distance down in here. And so I know what my y value here is, K minus this A would give me this y value for this line. So K minus A. Okay, so let's look at a different equation. Where's my green? It's gone. If your equation was in the form of x minus h, quantity squared is equal to -4 times A, all times y minus k. Vertex, same idea as above. It's HK. Looking at this, if you have an x squared value, your coefficient in front of the x squared, if you were looking at it, is negative, or if it's in this form, this is a negative value in front of this parentheses. If that's the case, then the parabola is facing downwards. So let's figure out how to locate those, the focus, the point of the focus, and the line of the directrix. Well, the focus is down in here. Well, this is again HK. I'm just changing my Y value of my point from my vertex to my focus. My X value is going to stay the same. So the focus is going to be at H, but this time I'm going to take my Y value, my vertex K, and I'm going to subtract that A value. So minus A. Where the directrix, that's the line above, equal distance. And so lines are always in the form of y equals. So it's just affecting again, the y value of your vertex. And so let's think of this was at HK, the y value is K. Well, let's add A to that, K plus A. Okay, let's change it up where we're having sideways parabolas. And so sideways parabolas are in the form, instead of your x value quantity squared, you have a square, you have a y value squared, and your x is not. And so if you have an equation in the form, or we can put one in the form so we can see what it looks like, y minus k quantity squared is equal to 4a all times x minus h. So the vertex, be careful here, it's still hk, but notice that the h is with the x values, not with a square. Because the coefficient out here in front of this x minus h, the piece that's not square, is positive, our parabola shape is going to be, think of it as facing towards the positive values of your x's. So your focus is always the point that your parabola faces that is equal distance from every point in here and the directrix. So, okay, anyways, and so here, notice that our vertex, to get this point for our directrix, we're just affecting our x value of our vertex. So we're just adding, and again, this is the distance of a. So we're just adding a. So our focus is equal to h plus a, but our y value stays the same, k. Where our directrix is y equals, no, it's not y equals. It's a vertical line, so it's in the form of x equals. Well, here is h, our x value is h, and we're going to subtract a to get to the x value of that line. And one more formula, and it's the other direction. So if we were going to face this way, instead, it's almost identical as above. Instead, you have a negative 4a in front. So it's y minus k quantity squared is equal to negative 4a x minus h. Vertex is still at hk, but our focus and our directrix have changed just a little. So from our vertex, hk, we're affecting our h value, we're going over a units, so it's h minus a. Oops, this is our focus, h minus a, comma k. And then for our directrix, it's a vertical line. It's always, parabola is always facing away from the directrix, going towards the focus. This directrix, it's a vertical line. Again, we can find out what that x value is by adding a to the x value of your vertex. So this would be the line h plus a. I just want to do one example before we take a break. Okay, so let's say it says find the vertex, focus, and directrix of each parabola. So find the vertex, focus, and directrix. And graph. Let's say it is y squared plus 12y equals negative x plus 1. Okay, so first of all, it's not in the form where I can tell what the directrix is or what the vertexes or focus. I can tell though that just looking at this equation, what conic shape I have. I can tell that this is a parabola. So parabolas are the only ones that don't have both x and y squared. And so if you see one that one of the variables in there isn't squared, like in this case, we don't have any x squares, then right away it should flag that this is a parabola. Depending on which variable is squared, flags which way it's facing. It's our y value that is squared, so I know that my parabola is either facing left or right. I know my a value actually is 1, and so it's actually going to go to the right, but let's show that. And let's find the vertex. So kind of similar to what we had done before in the past with circles, we notice that we need to complete the square. We need a perfect square here. And so if this hadn't already been in this form, I would have gotten all my y terms to one side, my x and constant to the other side. And so we want to complete the square. My value in front of my square, my coefficient is 1, so I don't have to get and make it 1 by dividing through by that. So that's nice. So all I have to do is look at what do I need to add to y squared plus 12y to make this a perfect square. Since I'm going to add something to one side of the equation, I'm going to have to add it to the other side. So it would be the same number you would have to use to add 12. Well, the same number you add by itself to get 12 is 6. The multiple of that number, 6 times 6. So 36 is that number that we were adding. So let's rewrite that as a perfect square. So now this is the same thing as y plus 6 quantity squared is equal to negative x plus 37. Okay, so notice that this is in the form of x minus h, x minus h. Notice in the parentheses that coefficient in front with the piece that wasn't squared is 1 in that parentheses. And so I need to make this a positive 1. And so we can do that by factoring out a negative. So actually this is going the other direction than I thought. So this is negative x minus 37. So this is in the form that I can tell what the vertex is. Well, hk, my h value is always with my with my x. So that is an opposite sign. So this is positive 37, comma, negative 6. So if I graph this, some 37 over here, negative 6 here, I have this point. I know because this value in front is negative that my shape is going to be facing towards the negative direction. Parabola faces towards the negative numbers. So it has to be this way. Depending on how big this is going to affect how wide or skinny our parabola is. So this was in the form out here as our formula was 4a. This piece here, 4a is equal to -1. So I need to know what A is in order to figure out where my focus is and where my directrix is. And so A, if I divide both sides by 4, I know that A then is equal to -1/4. So my focus is going to equal, well, my X value here minus my A value here. So 37 minus 1/4, comma, my Y value is the same, so -6. So really it's actually kind of close in there, huh? And so my directrix is the line, it's going to be a vertical line, so it's X equals. And so basically we're just adding 1/4 to my 37. Oops. I meant to, sorry. So X is equal to X. No, that's our focus. So this would have been 36 3/4, -6. Or X is equal to 37 1/4. Okay, so a lot of this chapter, when we look at graphing parabolas, ellipses, and hyperbolas, we're going to be trying to get things into the forms that look like this. They're going to have perfect squares in them. Just like with circles, ellipses and hyperbolas have a perfect square of your X terms and your Y terms. So let's take a break and we'll come back and we'll do some more problems. Pause this. Did we do it again? Okay, so we kind of left off at this problem and took a break, and I realized that we didn't really graph it so well. We could get some more points on here to kind of figure out more the shape of this, because we don't really know how wide or skinny this is. Actually, because of this distance here, my guess is that it's going to be pretty skinny. But we can find important points on this graph. We can find X and Y intercepts. When you're going left and right, it's possible that a graph might not cross, when the parabola is facing left or right, it's possible that it doesn't cross a y-axis. Just like when we were talking about when parabola is facing up and down, it's possible it didn't cross the x-axis. Same kind of general idea, but looking at where our vertex is and knowing the direction it's facing, we can tell if it's going to have that intercept or not. If we look back at our original problem, we can find the x-intercept pretty easy by just letting y equal 0. So looking at this, our y-intercept, I'm sorry, x-intercept's easier one. Let's do that one first. X-intercept, we're going to let y equal 0. What we would have is 0 squared plus 12 times 0, that's just 0, equals -x plus 1. Add x to both sides, you get x equals 1. Okay, so this is intersecting at 1. Technically, we could know another point of this graph because of axis of symmetry. This graph is going to be symmetrical across this horizontal line that goes through our vertex. And so if this distance here is 6, then the distance from the axis of symmetry down also has to be 6. So I really know I actually have a point at 0, -12 also. Not 0, 1, -12 also. Oops. To find the y-intercept, we're going to let x equal 0. Let's look at, we have two different forms. If we use this form right here, and we let x equal 0, then we can use our square root method. So let's find our y-intercept, or intercepts. Then we would have y plus 6 quantity squared is equal to 0 plus 37 is 37. So take the square root of both sides. We get y plus 6 equals plus or minus the square root of 37, which is just a little tad over 6. Subtract 6 on both sides. We get y equals -6 plus or minus something very close to 6. So I know that it's just going to be below -12, and it's just going to be -6 plus something a little bit bigger than 6 is going to be above the x-axis. So this wasn't drawn to scale, so it has a parabola shape though. So given information about a parabola or a conic section, you should be able to find the equation. So let's say that you're given that the...
I'm sorry, how'd you choose that point on the x-axis?
How did I choose the point? Over here or over here? This x-axis?
Yeah, the left side.
Down here? Sorry, the x-axis.
Yeah, how'd you choose those two?
I found the x-intercept. X-intercept, I went back and I let my original equation, I let y equals 0.
Oh, okay, that's what you did that. Okay, I'm sorry.
Yeah, and then I know about symmetry that it's going to have to be the equal distance between this axis of symmetry where it would be, that parabola would be symmetrical. I know I could do the equal distance down to get another point. So if I go down 6 to get this axis of symmetry, I'd go down another 6. That would give me -12, and my x value is the same one. Okay, so we're given that the vertex and the parabola is going to be 4, -2. And your focus is at 6, -2. Find the equation of the parabola. Okay, so we know it's a parabola. We just don't know if it's right now, if it's facing up, down, left, or right. And knowing which direction it's going to face is going to help us determine which equation to use. And since it's given us 2 points, the vertex and the focus, I know that my parabola is always going towards the focus. And so usually plotting what they give you is kind of helpful. And so plotting our points for -2, so going over to the right 4 and down 2. And plotting the point 6, -2, so going to the right 6 and down 2. I can tell right now that my parabola is going to face towards the right. So it's a sideways parabola. So just by plotting these points, I figured that out. And so because it's a sideways parabola, it's going towards the positive direction, I know a couple of things. Well, first of all, it's my y part that's squared. So it's going to be y minus whatever my vertex is, the k value, quantity squared, equals 4p all times, oops, I call it p because that's what my other book was. I've never seen it as a before, but 4a, your book calls it a, times x minus h. So we can put in some pieces that we know. Well, we know what h and k are. We're given that h is 4 and k is -2. We don't know what a is quite yet, but a is that distance between, you can find it by looking at the distance between that vertex and the focus. Well, if I'm going from an x value of 4 to an x value of 6, y hasn't changed, we can tell that that distance here is 2. Okay, so now we can just plug it all in. And we have y minus -2. So that will be y plus 2, quantity squared, is equal to 4 times a. So 4 times 2 is 8, all times x minus h, which is 4. So if it says focus is -4, 4, and the directrix is the line y equals -2. So again, we're trying to find the equation of the parabola. And so knowing and graphing, knowing what way our parabola is going is helpful again to determine which equation we're going to use, and then we can kind of pull out the pieces we need. Well, we know where our focus is. It's given it's -4, 4, so let's go to the left 4 and up 4. And then it's given us that the directrix is at the line y equals -2. So this is a horizontal line. And so y equals -2. So knowing where my directrix is, what way it's going, horizontal or vertically, knowing where my focus is, I can tell which direction my parabola is facing. Again, the parabola is always facing towards the focus, away from the directrix. And so to me, this has to be an upward parabola. I do not know right now where my vertex is, but I can figure that out pretty quickly. So let's just write, we know that it is upwards, and so that's going to be in the form of x minus h. Quantity squared is equal to, it's up, so it's going to be positive 4a all times y minus k. Well, basically, the value of a was that distance either from the vertex up to the focus, in this case, and the vertex down to the focus. And so that would have to be halfway distance between these two. So if this is 4 and this is y, oh, that was y equals -2. We can change it if we want. Let's just change it to +2 since I already graphed it. That would have changed that problem. But anyway, so now that this is y equals 2 and it's now. There we go. Sorry about that. So we know a has to be halfway. Or a is that distance in between here is 1 up and 1 down. So a in our case is equal to 1. And our vertex, well, that was the halfway point. Well, our x value going up or down is not changing. So my vertex, my x value h is -4. And by looking at the graph, we can tell that our a value, or our y value is at 3. So now we can just plug it into our equation. We have x minus h. So x minus a -4 is really x plus 4. Quantity squared is equal to 4 times 1, which is 4, all times y minus k, y minus 3. Let me look at a word problem real quick. Okay, so we got a bridge. It's being built in the shape of a parabolic arch and is to have a span of 100 feet. The height of the arch, a distance of 40 feet from the center, is to be 10 feet. Find the height of the arch at its center. Okay, so we got a bridge. Is to be built. The shape is going to be a parabola. Parabolic shape arch is to have a span. Oh, I don't know if it's going to go this way, or maybe we can look at it. Is that how you would look at it? I don't know. Okay. Would you look at it upside down? Anyways, this span is going to be 100 feet. The height of the arch, a distance of 40 feet from its center, is to be 10 feet. Height of the arch. Okay, so the height of the arch is going to be this way. Okay, so we got this here is 100. And we know the height 40 feet from the center. So we have some center, our vertex, or not our vertex, or center. So center would be from down from the vertex. That has to be 40 feet from the center. We know that this height in here is 10 feet. from its center is to be 10 feet. Find the height of the arch at its center. Okay, so it's a parabola. It's a parabola facing downwards. So we know that it's an x minus some h quantity squared equals, we can do this if we wanted to, this 4a y minus k. If we think of it that way, let's say, let me think. Well, we know a couple of things. It depends on really where we want to put our x-axis. But let's say we could actually put it here. We could put it over here. We could put it anywhere. So let's just put it here and down here. And so if we did that, that would tell me that my h value is going to be at 0. My k value, I do not know what that is. I need to find that height. That's the whole point of this right now. What else do we know? But I believe we know some points on our parabola. We're given 2 points, or 1 point, but we really have 2 points. We have this point here, and this point here. So 40 this way, we could say then that as x equals 40. My y value is 10. I also know when x is negative 40, my y value is also 10. So we know a y and we know a k, and we know h. Not sure about a, but we basically have 2 equations and 2 unknowns. So if I plug in what I know, I have right now, well, just x squared, because x minus 0 quantity squared, x squared equals 4a all times y minus k. So if we plug in negative 40, 10 for x and y, so my y value is 10, let's square it, equals 4, oops, there should be an a here, times a. I just said that, but I was wrong. My x value is not 10. X value is negative 40. I square it. 4 times a, y is 10 minus k. So negative 40 times negative 40 is 1,600. 4 times 4 is 16 plus 2 zeros equals 4a 10 minus k. Let's just distribute this 4a. So doing that, I get 40a minus 4ak. Okay, so here's one equation based off of this point. We're going to get another equation based off the point 4010. Notice that when we plug in those values though, when I plug in 40 and for my x value, I square it. This is equal to 4 times a. Y is still 10 minus k. So this also is getting me 1600, shoot, equals 40. I'm surprised. Okay, so we haven't even talked about nonlinear. This is a 40a minus 4ak. I mean, basically the same exact equation. So what I did didn't help us any way whatsoever. Okay, let me think about this. Let me just go back. We should be able to do this. Basically, we have some equation, could be written in the form also because it's a parabola, y equals ax squared plus bx plus c, right? We also have another point here. This point here, our y value is 0, and we know because this length is 100. So we also have that this is 50, 0, and this is negative 50, 0. So if we plug in values for x and y, if I plug in, let's say here, oops. If I plug in this point, sorry, this is 50, this is 0, this would be 0 equals a times x. X is 50 squared plus b times 50 plus c. If I plugged in another point, I know that y also has to be 0 is equal to a times negative 50 quantity squared plus b times negative 50 plus c. I have one more point. Let's do 40, 10. If I plugged in 40, 10, so y is 10 is equal to a times 40 squared plus b times 40 plus c. Okay, so my guess is this is not what they meant for me and how to go to solve it, but this looks like a way to solve it, and this is something that we're going to be covering next week anyway, so might as well just kind of talk about it. So notice this is going to be a system of equations, and you should have looked at systems of equations in the past. And so let's look at this and let's simplify this down. And so this is 0 is equal to a times 50 times 50. Well, 50 times 50, that's 25 plus 2 zeros, 2,500a plus 50b plus c. Simplifying down this equation, oops, we basically, no we don't. We get 0 is equal to negative 50 times negative 50, that's 2,000 or 25 or 2,500 a minus 50b plus c. And the last one we have 10 is equal to 40 squared, 40 times 40. So 4 times 4 is 16 plus 2 zeros, so 1,600A plus 40B plus C. So this is a system of equations. We made it so that we have 3 equations and 3 variables. The variable A, B, and C have to be the same thing in each one of these equations for it to hold, for that statement to hold. And so when you have more than 2 equations and 2 variables, then you want to start reducing it down like that. And so we can use elimination or substitution method. Elimination method is also called the addition method. And so basically we want to use one of these equations, doesn't matter which one, to get 2 of the equations to have just the exact same 2 variables. So we either want to get rid of C in 2 of the equations, B in 2 of the equations, or A. Only reason why I said C is because it's the same coefficient in front of all of them. So that to me looked like maybe that was the easiest way, even though right here I could add 2 equations and get rid of B. So let's look at it as, let's use, and this is a method that we're going to be actually using matrices to help us solve these systems when there are more equations and variables. And so you'll be able to see that next week, where we don't have to be writing down the variables each time. Matrices is just a way to order your coefficients of your equations and keeps everything neat and nice and tidy. But so we're going to use this first equation. I'm going to call it row 1, and I'm going to do it with a capital R with a little subscript. So I'm going to take this first equation and I'm going to multiply it by something and add it to the second equation so C goes away. So I'm going to look at negative row 1. And I tend to always do plus, so I always do here plus row 2. So technically, if I multiplied a negative 1 to this first row, this would give me negative 1 times 0. Well, that is just 0 is equal to negative 1 times 2,500 is negative 2,500 A. Negative 1 times 50, so minus 50B. Negative 1 times C minus C, and we're going to add it to row 2, which is 0 is equal to 2,500 A minus 50B plus C. So summing these 2 equations actually is really nice, because I now notice that I get 0 equals this negative 2,500 A plus this 2,500 A cancels. I have a negative 50B minus a 50B, which is a negative 100B. So right here, I already know what my value of B is, because negative C plus C cancels. So to me, that tells me B has to equal 0. So let's go back. Because we know what one of those variables is, we can go back and we can substitute it in here. Well, if we go back in and we plug in 0 wherever we see a B, those terms would go away, right? So let's look at, we have 0 is equal to either 2,500A plus C. Well, again, that's the same equation below, or 10 equals 1,600A plus C. Okay, so our goal was anyways to get down to 2 equations with 2 variables. That wasn't the one I set down to get, but it is this way. So I want to use, I'd probably use elimination method again, and I would choose a variable I want to get rid of. So multiply one equation by something so that when we add it to the other equation, it goes away. So notice if we multiply this equation, let's do the bottom, by -1, and we add it to the equation above. So this would really be 0 plus -10, that's a -10, is equal to 2,500a. Really, this is now a -1,600a. So that's going to be left with a 900a. And then -1 times the c. So c minus c is 0. So we can figure out what a is. So divide both sides by 900. This gives me -1 over 90. So that's my a value. I can go back in and I can substitute that in and I can figure out what my c value is. So I can plug it into any one of these equations. So let's go back into the first one. So 0 is equal to 2,500a, which is -1 over 90 plus c. So c, if I added this to both sides, so really I'm left with 250 over 9 is equal to c. Which is actually my answer, because that is the height and that's my y-intercept. Because now if I know what a, b, and c are, we knew that we had some equation in the form of y equals ax squared plus bx plus c, because it was facing downwards. This is y is equal to negative a, or a is -1 over 90, x squared. B was 0, so that goes away, plus c, and c is plus 250 over 9. So this is my equation for the parabola that we had made by centering it at right here. And so basically, if I let x equals 0 now, that would give me this height. And so if x is 0, then my height is 250 over 9. And so if we look at 250 over 9, we get about 27.8, or they go to the hundredths. So 27.78. feet. Okay, so there must have been, like I said, because we haven't gotten to that point of solving 3 equations, 3 unknowns, there must have been a way that we could have done that. I just didn't see it without having to do that system of equations, but maybe that's a good review for looking at those 3 equations, 3 unknowns of doing systems of equations. So when we get into matrices or when we do a couple of these examples, they'll go pretty fast.
Is that the correct answer? Because it goes up to 40 or 10. Never mind. I'm stupid. Never mind.
Yeah. Yeah. So
But I am kind of lost on how you just picked the points 50 and -50.
But that's, I knew I had to put it somewhere. I knew this distance in here was 100. And so I have to pick points that I know are on my equation, on my parabola. And since I centered it here where my axis of symmetry is my y-axis, and that length was 100, then it would have to be 50 over here and 50 over here, would give me a height of 0. And so I know that those were 2 points on the parabola. That was just easier for me because that was a y value of 0 instead of having to use, and I would have to use 3 points in order because I had 3 unknowns in order to get 3 equations that A, B, and C were in there.
Okay, so you could have also done it with the -40, 10 instead of the 40, 10.
Yep. So I could have chose, as long as I had 3 points on there and I chose them, that it should work out. And I only knew 4 of them on that I can determine right now on that graph. It should have worked out too if I had not put it there. So I could have started, and I could have said, okay, instead of centering it there at that origin, I could have gone out here where this was 100. Halfway point was the 50. And this is the height we're trying to find. We knew that 40 away from the center. So then this would have given me 40 away from the center. This would have given me a point of 10. So I would have had a point of 10, 10 here. I mean, our equation's going to look different, but we'll have the same answer in the end of our height. And this point here, if we had gone over 40, this would have given us 90. So we would have had a point at 90. And our height, it told us, was 10. So we would have had a point at the origin, 0, 0 on this graph, a point at 100, 0. And then I know 10, 10, and 90, 10. And if I would have used that information, same kind of process, I would have gotten that. I would have had to look at the height though when x was 50. I would have had to gone back in here, plug in 50 for x, and then that would have given me that 27.78. So to me, it was just easier to center it where axis of symmetry was the y-axis instead. So I think that is a perfect spot to stop. When we'll do more on ellipses and hyperbolas, which are kind of similar to this. So we need to talk about the exam next week. Pause.